And here's a super fun problem to think about. So you've got these two cities. One has a population of 300, and it's growing at a steady rate of 20 people per year. City B has a population of 20 and is growing by 10% each year. Is City B ever going to catch up? Will the cities ever have the same population? If they will, then when will that be? If not, why won't they ever catch up? I don't know. Do you have just a gut feeling about this? Whether it's yes or whether it's no? I'm going to do the math and see what turns out. So city A, let's have Y stand for how many people there are, and X can be how many years. So we're starting out with 300, a base of 300 people, and we're adding 20 people per year. That's like a slope, right? 20 people per year. So that's going to be a linear equation. City B has a population Y is equal to 20, but then it gets increased by 10% each year. Do you know how to increase by 10%? You want to multiply not by just 10%, but by 110%, because we want to keep those 20 and add an extra 20. And then that's going to happen each year. So if we keep multiplying by that same thing, that's raised to the x power. All right. So on year 0, we're at 300 in City A. Year 0, we're on 20 in City B. All right. Do you want to do graphing, substitution, or elimination? Let's decide. So these are already solved for y, so we could almost do a substitution and plug that in for there. So 300 plus 20x equals 20 times 1.1 to the x. I'm not sure I really know how to solve an equation that has a multiplied x and an x up here. I'd probably use a log, but then I'd wind up, yeah, I don't think that's going to work very well. So maybe I'll try elimination instead. You guys can choose whatever method you like, but you have to know how to do each of them. So if I do elimination, let's do this. So I'm going to line them up on top of each other. And I guess I have to make one opposite. So how about I multiply the second equation by a -1 on both sides. And then when I add them together, the y's are eliminated and I have 0 equals. So these don't actually really add together. You guys, this is the same. I just got the same thing as I got here. I basically have that same issue where I could use a log, but then then I'll have a log equation. So when you have an exponent, yeah, not gonna work. So I think I'm gonna go to graphing. So I've got those typed in, but then when I graph them, I'm really not happy with the graphs. The blue looks like a line, the red looks like an exponential, I suppose, but they're intersecting 14 years ago, and that's not really what the question's asking. So 14 or 15 years ago, they had 5 people each. So I need to play with the window a little bit. And it helps to think about what I'm really looking at as far X stands for years. I don't care what happened before year 0. I really don't know how long it's going to take, so I'm just going to guess 30 years and see what happens. But then I know Y stands for population. And that one city started at 300. Plus it's growing. So I don't know, I'll try 3,000, see if that's high enough. I'm just going to sort of take a stab at it and see what my graph gives me. So there's my linear graph going up 20 people per year. And there's my exponential graph growing by 10% each year. Does it look like it's going to ever catch up? See, here's the thing about exponential growth, though. Doesn't exponential growth eventually get really steep? Isn't that the idea of exponential growth? So I feel like maybe if I just widened it out here. So if I go to my window, and so maybe 30 years wasn't enough. Gosh, I'll try 100 years. Let's see. Is your calculator this slow? It just seems painfully slow. Okay, here's the exponential. Oh, there she is! Yeah! That exponential took over and then it just skyrocketed, didn't it, with that 10% per year? Once you get up to that many people, 10%'s a lot per year. Let's find that intersection of the y1, the y2, and I'm just going to hit enter on guess. And so it's telling me that about halfway through year 42, we're going to hit 1,150 people, and some on the way. So 1,150 people is when those are going to match. Cool. So usually I like to go algebraic, but on this one it just wasn't working out, so it took me a while. But I finally figured out that there were two intersections. There was one back here that nobody cared about, and then there was that one over here at 42.5, 1150 point something. So will the cities ever have the same population? Yes, actually. When? 42.5 years from now? So that's just kind of a fun example of how you can use it for problem solving, using solving systems of equations. I have just a couple more slides that are uploaded for you if you want to look at them, but go ahead and try this worksheet. These videos are also available for you to watch again if I was going too fast. It was supposed to be a review, but I know not all of us have that kind of memory, so feel free to go back and watch examples if you need to.